Welcome back, America, to another episode of Math with Dr. Math. We are here in Dr. Math Studios in front of a live studio audience. And the phone lines are open now at 1-800 Ask Dr. Math. So go ahead and copy this down and let's get this show rolling. All right. So, our first problem of the day in this beautiful Thursday morning. What we have going on is we have the Gulf Stream is a warm ocean current that extends from the eastern side of the Gulf of Mexico up through the Florida Straits and along the southeastern coast of the United States to Cape Hatteras, North Carolina. All right, so we got a boat and it's traveling with the current. So let's make a note of that as you guys are copying this down. So we got a boat and it's traveling with the current and it's traveling 100 miles from Miami. All right. And it's traveling from Miami to the Bahamas. And notice they give us a time. So let me go ahead and underline the time. They do this in 2.5 hours. All right, so we're just keeping track of all this. In the return trip, right, the return trip against the same current, the new time is 3 1/8 hours. 1/8 hours. So let's go ahead and organize all this in a chart so we could take care of business. So I see my phone lines blowing up. So let's start with Delaware. You're on the air with Math with Dr. Math. Go for it. Okay, I'm getting some notes from my technical producer that the sound isn't coming through live. So here's her question. Her question is, when we have a mixed number, are we going to need to change it to an improper fraction? That is correct, Delaware. So this number, I'm going to change this to an improper fraction. So let me go ahead and do that right there. So this is 25 over 8 right there. So notice, remember, we multiply these numbers and then we add the number on top. All right, so let's write down a formula. So we know that rate times time, when you multiply the rate and the time, that gives us a distance. Rate times time, that gives us a distance. All right, so let's use this to create our table. Let's do this, Johnny. All right, so we got a table going on. All right, so there's our table. And we have a few things we want to look at. Well, first of all, we're going to be going against the current, right? So we're going to be going against the current. And then you're also going to be traveling with the current. All right. And again, it doesn't matter which one you put on top, which one you put on bottom, as long as whatever you stick in here is consistent with your labeling. And again, I'm interested in the rate, I'm interested in the time, and when I multiply these two, I better get that distance. So let's go back to our word problem so we can fill out this table. So it's telling us a boat travels with the current, so with the current, 100 miles. So our total distance they're giving us is 100 miles. So that's 100. And the time that they're giving us is 2.5 hours. So we're going to stick that 2.5 hours, and that's the total time. So that's 2.5 hours. So the rate is going to be what's going to be challenging. Let's think about this. All right. So you have your boat. So you have some object. You have a boat, and it's traveling. But then in this case, it's traveling with the current. So the current is also going in the same direction. So we could see that these two, let's call the boat speed, let's say that's x, and let's say the current speed is y. Because they're both moving in the same direction, hopefully you could see that we are going to add those two amounts, and that's going to give us how fast we are going, because these two right here are going in the same direction. So that's going to be very important. All right, so if you heard someone say x minus y, just slap them. All right, because we're going with the current. All right, so now the return trip, while we're traveling back home, so the distance has to be the same. So let's go ahead and fill that in. So the distance must be the same. We're still traveling 100 miles. This time, the total time it takes, right? The total time it takes is 3 1/8, which we converted to 25/8. All right, so let's go ahead and let's write that right here, 25/8. All right, and this time, since we're traveling against the current, we have to think about our rate. Well, you're going to have your speed of the boat. So in this case, you're going to have the speed of the boat. It's going one direction, so we'll call that x. But this time you're going against the current, and the current this time is going to be headed the opposite direction, right? You're going against the current, against those waves. So here, we're going to have x minus y. Your boat speed minus the speed of the current. All right, so this is our setup. This is the most important piece of the problem here, because now we're ready to solve this. So let's go ahead and let's solve this. So let me move this up for you. All right. So once again, what you're about to see hasn't been done on TV ever before. All right. So just be ready to be amazed. All right. So what we're going to do here is, let's see. Let's get rid of this. Let's erase this. Give us some real estate here. So we have a formula that we copied down. And if you recall, our formula was rate times time equals distance. So what I'm going to do is I'm going to take this rate, I'm going to multiply it times this time, and it's going to equal this distance. So let's go ahead and do that. So I got my rate, which is x minus y. I'm going to multiply it times the time here. All right, so multiply it times the time, which is 25/8. And that's going to equal 100. So there's one of my equations. My second equation is going to come from right here. So I get the 2.5. I'm going to multiply it times x plus y, and that's going to equal 100. So let's go ahead and write that out. So I got 2.5. I multiply it times x plus y, and that's going to also equal 100. So this is where everybody's gonna, their approaches, their techniques are gonna be different. All right. So what I suggest is, let's get rid of these numbers in front. Let's get rid of that guy. Let's get rid of that guy. All right. So we're getting rid of this piece and we're getting rid of this piece. So let me, just for the sake of our notes, let me rewrite all this. So we got, let me start with the top equation, 25/8. All right, and what I'm going to do here is, first I'm going to multiply by 8, both sides by 8, so that those 8s cancel. All right, so those 8s are gone now. So I'm left with 25 times x minus y equals 800. All right, and then I don't want that 25 there, so I'm going to go ahead and divide both sides by 25. So I'm left with x minus y, and then I believe we're going to get 32. All right, so just double check that, but I think that's what we're left with. All right, so this is our first equation. And notice this is going to be much easier to work with. All right, so now let's take a look at our second equation. So let me move that guy out of the way. All right. So our second equation was 2.5, oops, let me try that again, 2.5 times x plus y, and that equals 100. So in this case, what we're going to do, same thing, we're going to divide both sides by 2.5. All right. So, any questions so far? Yes, Tim, you're on the air from Mississippi. All right, Mississippi. All right. So, what's your question, Tim? All right, great question, Tim. So, here's Tim's question. He said, "Do we have to divide by the 2.5, or can we just distribute?" You're more than welcome, Tim, to distribute. All right. That's perfectly fine. But what you're going to see is it's going to give you more work, Tim. All right. So my suggestion is to just go ahead and divide both sides by 2.5. So we do that and we're left with 40. All right. So here's our second equation. Nice. So now we have the two equations. So what I suggest using is the addition method. And that's the method that we looked at yesterday. All right, so let's raise all this. Let's move things out of the way here. All right, so let's work with these two equations. So our first equation is x minus y equals 32. Our second equation is x plus y equals 40. And what's nice about this is already ready to add. I don't need to change a thing. So let's add these two equations. And when we add the two equations, notice these guys are going to cancel. So we're left with 2x on our left-hand side. You're left with 72 on your right-hand side. We go ahead, divide by 2 and divide by 2. So x, which represents our speed of the boat in still water, is 36 miles per hour. So this is the speed of the boat in still water. And I think we're talking about miles per hour. We'll check the units. And now I just plug it into either one of my equations. So I end up with 36 plus y equals 40. All right. So therefore, we get y equals 4, I'll just say miles per hour. And this represents the speed of the current. All right, folks. So that's how we do it. So thanks for joining us for another episode of Math with Dr. Math, where debt is dumb and cash is king. So we'll be recording another live production in about 25 minutes. So hopefully we'll see you there, folks.